Hey everybody, welcome to today's lecture for mobile computing, and this is lecture 6, which I've entitled Some More Stuff About Objects. And you can probably tell from that title that it's going to be a fairly unstructured lecture. And what we're going to do in it is talk about some more stuff about objects. So, I keep talking about the fact that Java is object-oriented and that this is a good thing. And we've previously talked about the fact that object orientation helps with code reuse and maintenance, and it helps minimize mistakes. And that's cool, right? I mean, you take my word for it because I'm your lecturer and you're kind of forced to take my word for it. But the question is how? How does it do all of that? So in this lecture, we'll look at some features of Java and object-oriented languages in general, and we'll look at how they help with this code reuse and in terms of making mistakes and stuff like that. Okay, so the first feature we're going to talk about is the constructor, and the question is, what is the constructor for? So you've seen constructors in C++, and if you remember correctly, it's a method that kind of has the same name as the class, and we use it to kind of initialize variables and do some stuff. But what is it really for? Why does it exist? Well, we use it to specify rules and sort of procedures that must be in place before an object can exist. Okay, so I'm going to do the same thing I did in the last few lectures, and I'm just going to code in front of you, and most of it's quite unplanned, so you may be watching me make intolerable mistakes, but I'd actually love to hear from you guys about whether this approach is something that's useful. My impression of why it could be is that you can sort of pick up things that I'm doing in the code that I'm not even aware you're picking up, and that I'm not even aware that I'm doing, perhaps. So sort of watching can be helpful to pick up sort of things that are not explicit about programming, but you'll notice them while I do them. So I'm gonna write some code to illustrate what the constructor is for. And I have this sort of vague idea of what I'm going to do. So I've got a class called superhero in my project, and I've got another class called main. Okay, so the class superhero exists to store the details of superheroes. So let's say I had something like maybe a superhero has a real name and a superhero has a hero name. It has a hero name. So that's fairly common for superheroes. They have a real name and a superhero name. In my main class, I could then make use of the superhero object, make superhero class by making a superhero object by saying superhero s equals new superhero. Okay, and let's say the superhero has the real name, so s dot real name equals Pravesh, and s dot hero name equals Hulk. Yeah. What? You wouldn't like me when I'm angry, so don't pick on my superhero name. Sorry, I planned that and I'm kind of proud of it. So it's kind of sad. Okay, but similarly, we could have something like superhero T equals new superhero. And maybe for this one, we say T dot real name equals Richard. So basically, I've made a superhero S, and I've given him a real name and a hero name. I've made a superhero called T, and I've given it a real name called Richard. And so you kind of think, well, if I can just set these variables directly, why do I need a constructor? Well, what the constructor does is that it forces us to declare those variables. So in this case, let's say I said now I want to print out S's hero name. I could say sys out s dot hero name, and maybe s out t dot hero name. Hey, did you see that cool thing I did? I just pressed Control Space. If I type Sout and I press Control Space, then I get the whole thing. Anyway, add it out there. I think it's kind of cool. Yeah, but so, in this case, I've then got S's real name and T's real name. So if I run this program, it displays Hulk and null. And it displays null because Richard doesn't have a hero name in this system, right? So if I and that's a problem, right? Like it's kind of the hero has to have a hero name, right? Like it'd be a pretty rubbish hero if it didn't have a hero name. Like, you know, that, that'd be a rubbish comic. So what we can do is we can declare a constructor, so public superhero, and maybe what you have to tell the superhero is the real name and the hero name. Now this method signature on the top here saying that it's public superhero string real name string hero name, what that's telling us is that if you want a superhero object, you're going to have to give it a real name and a hero name. So that constructor sort of functions as some sort of contract. It says you can't have a superhero unless you define the real name and the hero name. So you'll see what's happened here then is that the constructor got underlined, right? Because it said you didn't give a real name and a hero name. If I position over it, it says I need to provide two strings. You see, it's superhero string string, and I've got superhero and nothing. So what I could do is go superhero Pravesh, comma Hulk, and then that would have actually resize some of this. I don't know if I can do that. Okay, that's a bit better. And then I could say new superhero Richard. And now the thing is, you see, I can't create a superhero with just a real name. I need to give him a hero name. And I'm going to give him the hero name Aquaman. Give him the hero name Aquaman because he's really powerful in sea. Sorry. I'm a dad. I have to make those jokes. Wait, am I still green? Let me sort that out. Okay, so now if I run it, wait, I got null. And that's interesting because I passed in a real name and a hero name, right? But the hero name still came out as null. The problem here is that what's happening is that this variable is local to this method. So if you remember the discussion of stack frames, it only exists when the constructor is running. This global variable exists everywhere, but it's not the same variable as this one. They have the same name, but they're not the same variable. So if I want to copy the value from this variable into this variable, I'll have to say something like real name equals real name. But that's not a reasonable thing to type, right? Because obviously a real name equals real name. What we can do to specify that the real name variable we're talking about is this one, the one that belongs to the class, not the one that belongs to the method. I can say this dot real name equals real name, and this dot hero name equals hero name. Okay, so what will happen then is when I create this superhero, Pravesh Hulk, it'll copy Pravesh into the real name variable and Hulk into the hero name variable. Okay, and similarly for Richard and Aquaman. So now when I do that, I get Hulk and Aquaman. Now the important thing about the constructor was that it made it so that I just wasn't allowed to create a superhero unless I gave it those variables, right? So the constructor is really useful for forcing particular behavior in your classes. And this becomes very important, especially when you're sharing code, because like, you might know that, hey, I have to actually give it a hero name. So I'm not going to bother with a constructor. I'm just going to remember to do it. But then when you share your class with the world, there's going to be some guy out there who's going to not put a hero name and then go, wait, why is all of this broken? Okay. The other thing a constructor can be used for is to like define particular behaviors that we need to happen. So let's say that our superheroes have got powers, and those powers are defined as strings. Okay. Now here I've just declared an array list, so something to store the strings. And then now I'm going to make a method, something like add power, string power. And what it's going to do is add that power to the powers list. Okay. And if I use that if I use that method in here, so maybe s.add power smash, then you'll see when I run the code, what happens is I actually get a null pointer exception in superhero.addPower. So that's in this method. So when it says powers.addPower, something is null here. Now we know it's not this string power because I fed it a value, it's smash. The problem is that powers, the array list itself, is null because I declared it, but I never actually created it. I never called its constructor, right? So if I really want an array list, I should create one. And the right place to do that would be in the constructor. So I can say powers equals new array list. Okay, so basically it's saying you've declared it, but now actually go and create it in, create an object in memory for it. So now if I run it, I won't get an exception. It'll just run, right? And Pravesh or Hulk will have the power smash. Okay, so don't make him angry. And that's sort of the purpose of the constructor, is that what it's doing is it's defining some conditions. It's saying, look, when we create a superhero, we have to do some things. We have to define their real name and hero name, which is why we had to pass them in. And we have to create their list of powers. Okay, so that we can populate it later using the add power method in this case. But the point is that the constructor was used for these tasks that sort of define what has to be done before you can actually have a superhero object. Okay. So I hope that made sense in terms of what the constructor does. Okay. Now, how does this help? Well, the important thing that you will have noticed is that we were forced to do certain things. Users of our superhero class were forced to do certain things. And by forcing them to do those things, it meant that we didn't have the opportunity to make errors, right? So we couldn't forget to put a hero name in there because the constructor would just not allow us to, right? We'd just get, if we forgot to put a hero name, the thing just got underlined straight away and the code just wouldn't run, right? So there's no possibility of a bug. Without a constructor, I could make a superhero and then put the hero name later, but only if I remembered. I might have forgotten, and then I wouldn't have a working piece of code. Okay, so that covers what the constructor is for. Another property of object orientation that's quite useful is something called inheritance. And what the property is for is to say that we can make sort of more specific versions of classes. Meaning we can make child classes that inherit the characteristics of their parents. What this means is that when we make a child class, that class will have all the methods and properties that the parent class has without us having to explicitly include them. Okay, so for my example now, I'm going to make a class called Sidekick, which is sort of like the sidekick of a superhero, right? So we've got the Sidekick class, and a sidekick is very similar to a superhero. So they're also going to have a real name, a hero name, powers, and they're going to need this constructor. And so I could do this. I could paste that. Okay, and change this to Sidekick. I could do that. That would work fine. Now I'll have a Sidekick class. But maybe the difference is that a sidekick has a superhero that the sidekick of, right? Which we'll call the, I don't know, main hero or something, right? So let's say that Pravesh was instead Batman, and then maybe we'd have a sidekick Q equals new sidekick. I don't know who would be Robin. I don't know. I'm just gonna say Robin. It's sort of weird to define one of the other staff members as being my sidekick. Unless let's pick Molefe. He's a tutor, so that's kind of like a sidekick. So Molefe is Robin. And then maybe I could say q.main hero equals Batman. No, the main hero shouldn't be a string because that doesn't really make sense. The main hero should be a superhero. A superhero main hero. So then I'd say q.main hero equals S because this superhero is the main hero of the sidekick. Does that make sense? I hope it does. But so that's one way I could go, right? So now I've got a superhero class and a sidekick class, and I've just pasted the code into the one from one into the other. But then let's say I later on decide, you know what, another thing that this class of item has is maybe a main color or something. I don't know why I'd want to do that, but let's say I did. Then superhero would have a color, but sidekick wouldn't. But really what I want is for sidekick to be exactly the same as superhero, except that it also has a main hero. So then I'd have to come into the sidekick class and put a color, right? The trouble is this may be like 2 years later and I've forgotten what classes even inherit from superhero, even supposed to be copies of superhero. So the problem is copying and pasting the code is fine. It works fine. I copy and paste code all the time. But the problem is that it's not sustainable because anytime you make changes to the class you copied from, you now have to like copy it again into the other class. And you could have like hundreds of subclasses, and then suddenly you have to copy your code into all of them. So what object-oriented languages allow for is like a automatic copy and paste, which is inheritance. So in this case, if I said extends superhero, right? So I'm saying class sidekick extends superhero. Then what it'll do is that a sidekick will automatically have all the things that the superclass has except the constructor. So we're still required to create a constructor, but we can use the super keyword to call the superclass's constructor. That keyword is not because the superclass is called superhero. It's just super just means that it's from the parent class. It's from the superclass. Because a common thing we do is we refer to the parent class, in this case superhero, as the superclass, and the subclass being the child, right? So when we do that, like the plus side is now we can, if we make changes in superhero, so we give it a color, the sidekick will automatically have a color because it just extends superhero. So basically what we get is we get that we don't have to put the code in two places. We don't have to like paste the code here. And pasting the code is not expensive, but maintaining that paste, so anytime you change this, you got to go change the other one, is expensive, like for a programmer. It's just hard work. What this extends does is it does the copy paste for us. So anytime we make changes to this top level one, let's say I decide I don't want to use an array list, I want to use a linked list. That's never a good idea, but let's say I did want to do that. I'm allowed to do that and it would work fine. Equals new linked list. But now because I changed it to linked list, it'll automatically change in sidekick because there's no code here. It doesn't know, it doesn't, it basically inherits the code from this one. So if I change it here, it changes there, which is really cool. So now when I make the sidekick Molefe and Robin, that means the sidekick is going to have a real name and a hero name, right? Which is great. I mean, considering I didn't have to write code for it, it just came from the superclass. And maybe, here I've got the same problem I had before, that you could forget to define the main hero. So maybe I make it part of the constructor. So maybe the constructor will be that you give it a real name, a hero name, and the superhero that is the sort of main hero of this class. So then I can call the superclass for the parts that initialize based on real name and hero name. And then on top of that, I'm going to say this.main hero equals main hero. And then that means I can set this to Molefi, Robin, and S, right? Because S refers to Batman. Okay. Did that make sense? So the whole point of inheritance was that I could just copy classes, copy methods automatically, but without having to explicitly copy them. It's just, I just say extends superhero, and I get all of those properties without having to actually, you know, repaste them or redo them. So yeah, that's pretty much what inheritance is. Another property that I think you probably have noticed is static. What does static mean? Why do we see the word static? What static means is that the variable or method that we're referring to is shared. That means that the variable doesn't belong to the object, it belongs to the class. Okay? And you can, let me show you what this looks like in code. So basically, let's say superheroes have a shared property that every superhero has this particular property, and maybe that property is that all superheroes are. I have no idea. Maybe. I was gonna say that maybe they all have a cape, but then I remembered that not all superheroes wear capes. So let's think about this. Maybe all superheroes have. No, not all. No, wait, that's the wrong thing to say. It's not that all it's that the class that is superhero has a particular property, and maybe it's that. Maybe we want to count. Okay, let's think of this. Maybe we want to count the number of superheroes. So we could say static int num heroes equals 0, right? And that would mean that there is a variable called num heroes, which doesn't belong to individual superheroes. It belongs to the superhero class. Okay, now what does that mean? That means that S doesn't have a num heroes property. Q doesn't have a num heroes property. T doesn't have a num heroes property, right? There's the static keyword, which means that actually belongs to superhero. Okay, so let's say I said s.num heroes equals 8. Okay, and here I said t.num heroes equals 9. If I printed out s.num heroes, what would you expect to get? I set s.num heroes to 8, and then I never changed it. So you might expect to get 8, but you don't. You get 9. Why do you get 9? Well, you get 9 because S doesn't have a num heroes property. Superhero has a num heroes property. So s.num heroes equals 8 is actually saying superhero.num heroes equals 8. T doesn't have a num heroes property. So when we say t.num heroes equals 9, because it's static, what it really means is superhero.num heroes equals 9. The variable belongs to the class, not to instances of the class, right? Not to objects. So now it's easy to see that when I'm printing out s.num heroes, I'm actually printing out superhero.num heroes. And that means what I'd get is 9, right? Java allows us to type s.num heroes and t.num heroes and stuff, but it doesn't mean what it looks like it means. And so that's why there'll be this warning. And if you click on it, it'll say, actually, no, like you should change it, and it'll let us just change it directly without typing code. Eclipse will just change it for us. But so it's important that is static. It just means that it belongs to the class, right? It belongs to superhero, not to instances of the class, so not to S. Now, what does that mean for methods? So let's say I had something like this here, public void change num heroes int val. And what it did is it set num heroes equal to val. Okay. Now, what's happening here is that we've got a method that is changing the value of num heroes, right? So, wait, no. Okay, that's fine. Ignore that whole bit. There's nothing wrong with that method. That method will work fine. Let's say I said now I've got a static method, public static change color. No, let's say change real name. String in. And what it does is it sets real name equal to n. Okay, so all it does is it changes the real name to whatever's passed in. And you'll see that it says cannot make static reference to the non-static field real name. So what does that mean? Well, basically what it means is that the method is static. It belongs to the class, not to an object, right? And what it's trying to do is change the real name, but the real name doesn't belong to the class, it belongs to an object. Now, when something is static, we call it as superhero dot, right? So let's say I said, okay, let's do it here. Let's say I said superhero dot real name equals Bruce Banner. I feel like that. So if I say superhero dot real name equals Bruce Banner, would that make sense? No, it wouldn't, right? Because, like, which superhero? Does it mean this one T, or does it mean this one S, or does it mean this one Q? Q is a sidekick, but because sidekicks are superheroes, you know, he could also be the superhero we're referring to. So that wouldn't work, right? So similarly, I've said that this method is static, which means it can be called from the superhero class directly. I could say superhero dot change real name to Bruce Banner, and that would try and set the real name to Bruce Banner. But whose real name? It doesn't make sense, right? Whose real name am I changing? I can't call superhero to change real name, because whose real name am I talking about? So static methods can only deal with static variables. So here, if I said that it was not static, if it was just change real name, that would be fine, because then I can't call superhero.change real name. I have to call s.change real name or t.change real name. By putting that static there, I was saying that you can call it on superhero, on the class itself rather than on the object. On the other hand, this public void change num heroes, that one I can make static. It's fine because it only operates on static variables. So if I said superhero.change num heroes to 5, that would be fine, because I don't have to care which superhero it's referring to, because num heroes isn't something that belongs to an individual superhero. It belongs to the superhero class as a whole. Okay. So yeah, that's what static means. Static means that it's a variable that belongs to the class, not to an instance of the class, so not to an object. But something I mentioned in passing there, which I think is actually quite important. You know, here it says sidekick extends superhero. What that means is that a sidekick is a superhero. So when I say sidekick Q equals new sidekick this, right, new sidekick with all of this stuff, I'm getting a sidekick object, but a sidekick object is also a superhero object. So if I said like that I've got a, let's say I've got an array list of superheroes. So array list of superhero league equals new array list of superhero. Then who can be in the league? Well, I can put in S. So league.add S. I can put S in there. That makes sense because it is an array list of superheroes. Could I put, for instance, a string? Let's say league.add Archie. Archie is a string, right? So Archie is no hero. So I can't add Archie to the league. But I could add Q. But that's weird, right? Because Q is not a superhero looking at this. But Q actually is a superhero because sidekicks are superheroes. Okay, so I can put Robin in the league if I wanted to, and it would be fine. Okay, this thing where Q is both a sidekick and a superhero is called polymorphism. You don't really have to care about that. Basically, all it means is that it can take two shapes. Polymorphism, right? Poly means many and morph means shape. So Q has the shape of a sidekick and it also has the shape of a superhero, which means if we try and stick it into a list of superheroes, it'll work. If we try and stick it into a list of sidekicks, it'll also work. Okay. So yeah, that was just an aside, but hopefully that bit helped you understand what static means. Sometimes all of this stuff is much clearer when you're coding, but if you remember some part of that discussion and then when something weird happens in your code, you can always refer back to this piece of the lecture and go, hey, that's what he was on about. Okay, the next thing I want to talk about is overloading and overriding. So overloading means that we can use the same method name with different arguments, and that would actually indicate different methods. Okay. Overriding is when a subclass replaces a parent's method with its own. So, man, I should definitely plan more. I'm trying to think now of good things I can do here. Okay, so let's say I've got this add power method and it adds a power to the array list. I could also have something like public void add power, maybe that has power 1 and power 2, and it's a completely different method, right? So maybe it'll say powers that add power 1 and powers that add power 2. I mean, I don't have to make it do that. I could make it do anything I want. The point is, these two methods have the same name, but they're different methods. But they're different because they have different arguments. This one takes one string and this one takes two strings. So I could say t.add power talk to dolphins. Aquaman's garbage. Talk to dolphins. What else can you do? Blow bubbles. He's like bubbles come out of his out of his trident. That seems pretty rubbish. Swim. It's a stupid power. Okay. So I could say t.add power, talk to dolphins, and swim. And both of these calls are calling methods called add power, but they're calling completely different methods, right? This one is calling this method, and this one is calling this method. Okay. Okay, so the point is I could have methods with the same name and they mean, they could mean the same thing, or you know what I mean. Then let's say I had a method here, maybe public void to strings. Let's say print, and maybe it did system.out.println hero name. Okay. Then if I said t.print, I would get the word hero name because I'm an idiot. Let me take that out of the string literals. I was printing the literal hero name instead of the variable hero name. Okay, now I printed Aquaman because T's hero name is Aquaman. If I did q.print, this is quite cool. It'll print out Robin, right? Because Robin, the sidekick Q, now automatically has a print method, even though I never defined one, just because it inherited it from the superhero class, which is pretty cool. But let's say what I wanted to do is if the superhero is a sidekick, I want to print out the superhero's name as well as the real hero's name. Just, so that you always know that actually this guy's a sidekick. Then what I could do is I could take this print method is inherited, right? Just like everything else is inherited. So the sidekick has the same print method as the superhero. But that's not what I want in this case. I wanted to have a different print method that also prints out the main hero's hero name. So what I could do is I could just make a print method here and have it do something different. So maybe hero name plus sidekick 2 and then main hero dot hero name. Okay, so now that means it's going to print out the sidekick's name and say sidekick 2 and the main hero's name. So now when I run it, it says Aquaman for the superhero and it says Robin sidekick to Batman for q.print. So basically what I did was I overrode the superclasses method. So although the superclass had a print method, I wanted a different print method in the subclass. So I made a separate print method. Okay. So that's all overriding means. Is sometimes you want the subclass to have a different action for the same method. Okay, and then all you do is you can override it. Okay, hopefully that was useful. Again, it's something you'll come across when you're coding. And that brings us to something called abstract methods. Now, abstract methods, so I said these subclasses can override the method from the superclass, right? But what if what I want is for the subclasses to have a particular method, but I don't necessarily want the superclass to define that method because there's no sensible way for it to define it. Okay, so let's look at that in code. So let's say now what I did here was I had this league and it had S and Q in it, and maybe just for completeness, I'm going to add T to the league. And then what I can do is something quite cool. I can do a for loop over everyone in the league, right? So I could say for int I equals 0, I less than league dot size. Sorry, my kid is crying. I'll be back in a second. Okay, I'm back. So yes, I was busy saying that you can do something quite cool. You can iterate over the items that are in the league. So you could say for int I equals 0, I less than league dot size, I plus plus, league dot get I, meaning get me the ith item from the league. So it's going to be S, then Q, then T. And what I want to do with that maybe is I want to print. Okay. So that means now I'm saying rather than calling print on each individual hero, I'm going to iterate over the league and just tell everyone in the league to print, basically, which is kind of cool. Lots of languages, Java included, also provide an iterator in the for loop. So I could say something like for superhero H in league, meaning for every superhero in the league and call that superhero h.print. Okay, so what that means is in turn, the superhero S is going to become H, then the superhero Q is going to become H, then the superhero T is going to become H. So if I say h.print with this for loop, I'm saying basically the same thing I did with that other one for int I equals 0, that sort of thing. And both of them are completely valid ways to do this, right? There's nothing really wrong with that. Okay, so I could print out the I could call the print method by just iterating over the items in the array list. Now let's look at a different structure, something else that might be interesting. Let's say I had some different types of superhero. Let's say I had a class of superheroes called maybe Marvel heroes. So I had like a Marvel hero, and maybe I had a DC hero or something. Maybe, are there any other comic book universes? I don't really know. I'm gonna make an Archie hero, as stupid as that sounds. Um, and let's say all of these extend superhero. So Archie hero extends superhero, and then that means it just needs that constructor, which Eclipse just added for me, and maybe DC hero as well. You may be wondering where I'm going with this. Just bear with me for a while. I won't take too long to get there, I promise. Extends superhero. So that means I've got the class Marvel hero, and every Marvel hero is also a superhero. Every DC hero is also a superhero. And perhaps less justifiably, every Archie hero is also a superhero. Let's move them over to this side where all the heroes go. So now let's say the only difference is that these guys have a method that tells us which universe they're from. So maybe public string get universe, and what it returns in DC's case is DC or DC universe. I don't know what the DC universe is called. It's called the DC universe now. And Archie has a similar thing. Okay, let's just paste the one from here. Archie has a similar one, except it says Riverdale. And Marvel has a similar one, except it says Marvel Extended Universe or something. Okay. Now, all of these are DC heroes, aren't they? It doesn't matter. I'm going to pretend one of them is a Marvel hero. I'm going to pretend Aquaman is a Marvel hero. So let's say I said now, Aquaman is actually a Marvel hero, not directly a superhero. Marvel hero. So Marvel hero is a superhero, so it doesn't change anything. I can still put Aquaman into the league. Okay, let's just change it because for some reason it's making me upset. Let's say Spider-Man, right? I have no good reason for why Richard is Spider-Man. And Pravesh is now a DC hero. And it's fine because the DC hero is a superhero, so there's no problem. I can still add Batman to the league. I'm gonna get rid of Robin because what purpose does he even serve? Okay. Then maybe what I want to do is look. S is a DC hero, so he's got a get universe function, and T is a Marvel hero, so he's got a get universe function. So I could, for every superhero in the league, I want to print which universe they come from. So I'm going to say system.out.println h.getUniverse. Now it's telling me, wait, no, you can't do that. Now, why is it saying that? I mean, S does have a get universe because S is a DC hero and that has a get universe. And T is a Marvel hero and that has a get universe. So it should let me do this. It should let me print out h.getUniverse. But why it doesn't is because superhero, H is a superhero. And superhero doesn't have a get universe method. Look at superhero, there is no get universe method. And if we wanted it to have one, public string get universe, what should it do? What should it return? I mean, what would the universe be? Unknown? I mean, that doesn't make sense because, I mean, there's no, it's not from a universe, right? So what's happening here is that we need superhero to have a get universe method so that this sort of thing will work. But we can't reasonably define what get universe looks like for superhero, meaning we don't know if it's DC, Marvel, or Archie. So what we need is we need some way to define that method without defining it. And why do we need to do that? We need to define that because what if I had a sidekick? What if I said sidekick q equals new sidekick Molefi. I should never have deleted this. Robin S, right? Then league.add q. Now league contains a sidekick, and sidekicks don't have a get universe. So could this for loop work? I mean, when q got copied into h, when h took on the value of Robin, and we called get universe, what should Java do? Right? Because the sidekick doesn't have a get universe method. So what we need, if we want to use this sort of code where we can just iterate through all the superheroes and call a method, is we need to guarantee that all superheroes will have a get universe method. Okay, we want some sort of contract that specifies that superheroes must have a get universe method. And that's what an abstract method is. So what we can do is we can say public abstract string get universe. And what that would do is it would say, I want all subclasses to have a get universe method, but I don't want to define it here because it doesn't make sense to define it here. So then I have to change the class to being an abstract class, and all that means is that that there's some abstract method in it. And then this get universe method, all subclasses must have a get universe method. So now sidekick, it's saying no. This doesn't work. So what Java tells us is sidekick has to have a get universe method, and there's no way around it. Now for sidekick, it's quite easy because we can just make sure that it's in the same. We can just return the main hero's get universe, right? Because the sidekick must be in the same universe as the hero that he is sidekick to. So you'll see we've got DC, Marvel, DC. So Robin automatically ended up in the DC universe because that's Batman's universe. Okay. But you'll see this code now worked. I could call h.getUniverse, even though superhero doesn't have a getUniverse method. Because of this contract that says that all subclasses must have a getUniverse method, this for loop could rely on the fact that h would have a getUniverse method. Okay, so all an abstract method is a contract that says subclasses must define this method. There's no way you can be a subclass if you don't define this method. That's why sidekick, when it didn't have this getUniverse method, it got a red underlined to say, hey, sort it out. But once we added it, it was fine. Now, one downside of declaring it, making an abstract method, is I'm now not allowed to make a superhero. I can't say superhero J equals new superhero Archie, Archie, because that's his real name and his superhero name if he is indeed a superhero. I'm not allowed to do that. And the reason I'm not allowed to do that is because superhero doesn't have a getUniverse method, which means this for loop wouldn't work. Right? So I can make a DC hero, which is a superhero, because it has got a get universe. I mean, not a get universe, a get universe method. But superhero itself doesn't have a get universe. Okay. So Archie was a bad example because I could have just made him an Archie hero. But let's say there's another hero, Spawn. Spawn is not in the DC or Marvel or Archie universes. I don't even know what universe is in. But the point is, he doesn't have a get universe method. Okay, so I can't just make a superhero. What I could do, though, if I wanted to, is I could give him a get universe method right then and there, like just in the code here, and then it would be fine. I could do that. So let's give him the universe. I don't know what his universe is called, so I'm going to call him Spawnverse or something. Okay. And now if I said league dot add j, then I ran it, I'd get the spawn verse for spawn. But notice here I didn't bother making a subclass explicitly for the spawn verse hero. I just gave him his get universe method right then and there. Okay, so Java does allow that. I could have done that for DC hero or something if I wanted to, but I felt DC deserved a universe thing and spawn didn't. No, but yeah, so you can define, this is sort of defining a subclass inline. So it's saying that what I'm creating here is not exactly a superhero. I mean, it is a superhero, but by adding this add-on, I'm saying I'm getting a subclass, an anonymous, unnamed subclass of superhero that has this get universe method. Okay, so I could do that. But yeah, the point of all of this was to say that an abstract method is just a method that we're saying must exist, but it's not sensible to define it in the superclass because it just doesn't make sense in the superclass. It only makes sense in the subclasses, but those subclasses have to define it. Okay, I realized that was a bit of a complex one. We're getting close to done though, so if you're still with me, good work. Okay, and the last thing I want to talk about is interfaces. Interfaces are sort of like classes, but they're made up entirely of abstract methods. So what that allows us to do is kind of define these contracts without sort of defining a class. Now, actually, wait, before I move on to that, we had this abstract method thing. A place you can encounter them in the real world is like, in Android, you can add like a edit text or a text view or a button or something. You can put all of those things on the screen. And all of those things have the superclass view. All right, so they're all views. And what Android is doing in the background is, in order to draw them on the screen, it's going to iterate over all of its views and call their paint method or their draw method, right? But view itself doesn't have a paint method because what is there to draw in the superclass, right? The subclasses like edit text, you know how to draw in edit text. It has to be like a box with white background and whatever. It knows how to draw a button, like, so the button has a draw method because it knows how to draw itself in a way. Edit text has a draw method, but view doesn't have a draw method because what would you draw? Is that view a button or is it an edit text? So view has an abstract method called draw, and the Android system will just loop over all views calling their draw methods, and they all have their own draw methods, right? So view has an abstract draw method, and then the subclasses have these individual draw methods. Okay. And that's one way to handle it. Another way to handle it might be through interfaces. So interfaces are, like I say, they're sort of like classes, but they're made up entirely of abstract methods. So I'm going to make an interface here. I'm going to call it drawable. Okay, so I made an interface called drawable, and all a drawable has is the ability is that it has an abstract method, public abstract void draw. Okay, so all drawables have a draw method. Okay, now let's say I said that superheroes are drawable. How I would do that is I would say public class superhero implements drawable. Okay, so that means that it implements this interface drawable over here, which was public abstract void draw. But by saying that, what it means is that superhero must have a draw method, or its subclasses must have a draw method. Basically, somewhere there has to be a draw method, right? So let's say I gave superhero a draw method, so public void draw. So you see everything's all red at the moment because I don't have a, but now as soon as I make a draw method, all that red disappears. And so maybe how the draw method works is that it draws a superhero. Yeah. I think he needs a cape. Okay. The problem is backslash is a weird character, so I have to do that. But anyway, that's as maybe. So now let's say now what I want to do is I have a collection of drawables. Okay, so let's say I have an array list of drawable shapes equals new array list of drawable. Now that array list can store anything that is a drawable. At the moment, superhero implements the drawable interface. So any superhero is drawable. So I could say shapes.add s, shapes.add t, shapes.add j, and then okay, let's change this for loop then. So let's say for drawable h, okay, let's call it d in shapes d dot draw. Okay, then when I run it, I print out a whole bunch of superheroes. Okay, it's kind of hard to see who they are. Let's give them, let's do that plus real name. No, not the real name. That might endanger innocent civilians. So if I did that, now I'm printing out Batman, Spider-Man, and Spawn. Okay. Now, why did I need that interface? Well, the cool thing about interfaces is I can use them to group together things that are not really logical things to group. So let's say I had another class called square, and it extends drawable. A square is not a superhero, and a superhero is not a square. I don't think he is anyway. Not extend implements drawable. Sorry, because drawable is not a class; it's an interface. And then that'll mean a square has to have a draw method, and so the draw method might be. I should have picked a circle, shouldn't I? Okay, well, I don't know. What's a good way to draw a square? I don't know. Okay, that's a square. Now, the thing is, if I said shapes.add new square, I now have a collection that has like two superheroes and a square and a and another superhero. And if I run it, it runs fine. I get Batman, Spider-Man, then the square, then Spawn. And I can do that because the squares are drawable and the superheroes are also drawables. And the reason I wanted to group them into drawables is because I wanted to draw them, right? So the interface allowed me to capture that these all have some shared functionality, even though they're in no way related, right? So by having this interface, I could now stick them all in a collection, and I could loop over that collection and call that shared function. Okay, so the important thing was to allow me to do something like this. And you can picture that that's what Android is doing when it draws all the components on the screen, right? It's calling like t.draw or something, and then they all just draw. In your case, you'll encounter it later on in the course when we start learning about web services. Hey, web services. Maybe that's why Richard is Spider-Man. Yeah. Anyway, later on when we're doing web services, you'll see that you'll need to implement some abstract methods simply because each class will need to talk to a different web service, right? It'll need to communicate with a different web site, basically, or a different database. And so you're going to have all of these classes that all have to communicate and update themselves, but they do it in a different way. So they'll all have this method that you can iterate over, but they'll have a different actual functionality inside, right? So like the squares draw method is very different from superheroes draw method. Okay. So hopefully that gave you a good introduction to why all of this is useful. Or no, I'm not sure that it would have done that. But what hopefully that allowed you to do is understand that this functionality is there, and then later on, when for some reason you happen to be looking for a way to accomplish something, hopefully this lecture will come back to you and you'll be like, what I need is an interface. And yeah, that'll that'll make me very happy if you let me know about it when you do encounter it. Okay, so that was a bit of a long lecture, but I think it was quite important. I've already heard quite a few questions about what does static mean, and that alone probably was a useful discussion. And yeah, thank you for listening to me, and I hope you enjoyed it. And I do very much appreciate comments and suggestions. So please, when stuff doesn't work, or even when it does, please do let me know. Do I have any? Yeah, one last thing that's not particularly related, but I'll just do it anyway. So let's say you let me make another class. I just want to talk about the main method a little bit. Let's make a class called program. Okay, so sometimes you've got a class called program, and no, yeah, main, that's fine, main method. See, I just typed main and Eclipse gave me. Anyway, that's pretty cool, right? And you've got some other method, public void print, and it prints hello world. And you don't want this method to be static. You want it to belong to instances of the class. If you say print over here, Java says, no, wait a minute. The main method is static, so it can only operate with things that the class itself owns. It can't call print because print is not static, which means it belongs to instances of the program class. And there's no instance of the program class here, right? What you can do is you can say program p equals a new program, and then you can say p.print, and that would work. Okay, so inside program's main method, we're creating an instance of the program class, and then on that instance, we're calling the print method. You could do that. Okay, so sometimes that's a good way to structure things if you have methods that sort of should belong to an instance conceptually, but you need to call them from the main method. Another thing you can do is make a constructor. So public program, and maybe in that constructor you could call print, and then that means over here, if you just said program p equals a new program, that would call the constructor, which would call print, but it would be calling print inside the instance of the class because it's inside the constructor. Okay, that was a bit of an aside. That wasn't something I was intending to talk about, but one of you asked me about it on Discord, and so I thought, let me stick it in the lecture because probably a lot of you are wondering about it. Okay, and on that note, yeah, let's call an end to this extremely long lecture. Thanks everybody for listening, and please make an extra effort with your labs. That's the cheat code to passing and the cheat code to becoming an awesome computer scientist. That's the important thing, right? You want to know how to program. Passing is necessary, but passing is not sufficient. You want to be awesome. Okay, thank you everybody.